Hi, today we are going to discuss about standard signals, and these standard signals are also called as elementary signals. These signals are used as input for studying the system's behavior. So first let us discuss about step signal. And this step signal is an important signal used for analysis of many systems. For example, when we apply a brake to an automobile, we are applying a constant force. That constant force is called as step signal. If a step function has unity magnitude means then it is called as unit step function. The mathematical representation, that is we can write this step signal as, that is, u of t is equal to 1 for t is greater than or equal to 0, 0 for t is less than 0. Here the magnitude value is 1, that is a unit, so we can call this as unit step signal. For that reason only here the function is represented as u of t. Okay, here the interval, the function exists only when t is greater than or equal to 0. It means that the function will be only in positive side. See, when I started to apply this interval, that is when t is equal to 0, u of 0 is also is 1. Now when t is equal to 1, u of 1 is equal to 1. When t is equal to 2, u of t or 2 is equal to 1, because we don't have any t variable here. Okay, it keeps on increasing. When we are in a situation to apply this till t is equal to infinity. When I represent this in a graphical representation means, that is here the x-axis is t and y-axis is u of t. Okay, here when t is equal to 0, the u of 0 is 1. When t is equal to 1, u of 1 is equal to 1. When t is equal to 2, u of 2 is equal to 1. Okay, since it is a continuous time signal, we need to draw in the diagram should be in a continuous manner, so it goes on, it keeps on increasing. When it comes in negative side means, here the t is equal to, when t is less than 0 means the function u of t is equal to 0. So we can draw this as, by drawing the shaded line, I'll be representing its function as 0. So let me take one here. This is the basic graphical representation of this unit step signal. Okay, so this is for continuous time. When it comes for dt time, dt type means we need to represent, instead of this t, we need to represent it as n, that is u of n is equal to 1 for n is greater than or equal to 0, and u of n is equal to 0 for n is less than 0. Okay, this that's all about step signal. We'll be moving to another signal, that is ramp signal. Ramp signal will be will be giving the name for this ramp signal as r of t. Okay, the r of t is equal to t for t is greater than or equal to 0, and the function becomes 0 for t is less than 0. Here also let us substitute this interval, that is when t is equal to 0, r of 0 is equal to 0. When t is equal to 1, r of 1 is equal to 1. When t is equal to 2, r of 2 is equal to 2. Here the amplitude values varies because the function has t variable. Okay, next let us draw this ramp signal in a graphical manner. Here also the x-axis is t and y-axis is r of t. Okay, for t is equal to 0, the amplitude, the r of 0 is 0. When t is equal to 1, r of 1 is equal to 1. When t is equal to 2, r of 2 is equal to 2. It keeps on increasing. straightly. Here the slope between 2 points is 1. For that reason only we'll be calling this signal as ramp signal. Okay, when it comes in a DT type, here one more thing, sorry, I forgot to say this, that is in negative side the function is 0, so the graphical representation in a negative side we can draw like this. Okay, negative side, positive side will be getting one straight line. Okay, next we'll be moving we are in a position to represent this by means of DT type, that is R of n is equal to n for n is greater than or equal to 0, 0 for n is less than 0. Okay, so here let us draw the graphical representation for ramp signal. Okay, the ramp signal, since this is a ramp signal, we need to represent the x-axis by means of samples, that is n, and y-axis is R of n. Okay, here also we'll be getting it as when n is equal to 0, R of n is also 0. Okay, when n is equal to 1, R of 1 is equal to 1. When n is equal to 2, R of 2 is also 2. Okay, here also it keeps on increasing, but this is not a CT type, this is DT type, discrete in time. So we need to draw like this. This is for n is equal to 3. Okay, positive side, here also the slope is 1. Now when it comes on a negative side, here the function, by seeing this function we can clearly understand that for n is less than 0 the function is 0. So here this comes like this. Okay, this is a ramp signal. One more thing is that I forgot to say that this unit step signal for DT type. Okay, here also let us draw our unit step signal, that is x-axis is n samples and y-axis is u of n. Okay, here for n is the function exists, the function value is 1 for n is greater than or equal to 0. When n is equal to 0, the u of 0 is 1. When n is equal to 1, u of 1 is 1. When n is equal to 2, u of n is 1. Okay, this is our DT type. So discrete in time goes till infinity. When it comes on negative side, the function is 0 for n is less than 0. Since this is DT type, we need to represent the samples like this. Okay. Remaining we'll discuss in next video. Please subscribe and share if you like my videos. Thank you.